This conference will now be recorded.
Uh, I'd like to thank everyone for showing up today to the importance of connector inspection. Today, Tammie Davis from our office will be presenting. Tammie's background, she's actually one of our sales territory managers here for S&S Solutions, but Tammie brings an extensive hands-on background in telecommunications to our company. For 16 years, she had worked with CenturyLink as a technician, an SME, a trainer, and a senior engineer. And from there, she joined EXFO as one of their technical sales specialists, teaching people about fiber optics and Ethernet, doing training classes, and overall helping them progress with their equipment. With her extensive background, it allows her to get to the tech level since she was there and actually work with them and help them achieve what is needed in their work. So without further ado, I will turn it over to Tammie Davis.
Thank you, Charlie. As Charlie mentioned, I do have hands-on experience in the industry in various capacities. And one of the things that is very, very, very important for me when I'm meeting customers, when I'm holding any training sessions, is to make sure we, the techs, know the importance of the roles and the jobs that we do. So, you know, there's engineers, there's planners, there's developers. They put together these networks. There's equipment manufacturers. There's so many moving pieces in the puzzle of getting a network up and running. And the physical layer is by far the most important part of that equation. So the technicians, you know, the decisions are made at a higher level. We're then expected to make sure all the, you know, cogs and wheels and all pieces work and work cohesively. Because at the end of the day, it doesn't matter if you have a Wi-Fi network, an RF network, a microwave network, these pieces are connected. And they're all connected with our physical layer, and that's the cable itself, the glass itself. If there's a problem in our glass, we have a problem with our signaling and delivering our services. So the big thing we used to watch for is, oh my God, who cut the glass, who cut the cable, let's go fix it. We were, you know, as an industry evolution, we started with mechanical splicing, we got into fusion splicing, we've gotten into bend and sensitive cable, and technology and our manufacturers are evolving the product.
Anybody here?
Hello? Can you hear me?
Yeah, I can hear you. This is
Yeah, we're
Eugene.
good.
I'm here.
Okay, sorry about that.
Part of the thing is whoever is organizing the event has to approve the.
Okay, that would be Charlie. That's on Charlie's end. But we're trying to evolve. Technology is evolving, and components and products are coming out to be more fine-tuned. And at the end of the day, we still have the tools we need to make sure the fiber optic structure is working as efficiently as possible. One of the biggest things is insertion loss. We still have not developed cable that will go from California to New York as a home run. It needs to be connected into different systems. It has to have a little bit of amplification, some regeneration. And so our fiber optic cable is going to pass through other components. So when we're creating our loss budgets, we have a network equipment manufacturer that has designed their transport gear, and they've decided, hey, our thresholds, our loss budgets must meet or exceed these standards. And they have numbers for the insertion loss, for the return loss, for the splicing loss. There's a note. So for today's demonstration, I'm going to do a fiber inspection. I'm using the EXFO FTB1 Pro chassis. You can see on my screen, for those of you that have joined this through the web, that you're looking at basically a PC laptop, desktop. You're looking at all these icons, a lot of this stuff. These are EXFO software products, and this works as a functional as you would your PC. This is running Windows 10.0, and you're able to download third-party software. You can use email clients. You can use remote desktop programs. And without going too much further into the FTB unit, we're going to actually go in and talk about connector inspection and performance. Before we do, I have this little sticky note sitting on the desktop, and it talks about what insertion loss is. When we talk about our connectors, where a physical pairing of fiber meet at a bulkhead, a patch panel, we need to discuss insertion loss. Insertion loss is loss that has been inserted to a path, a fiber link. So from point A to point B, not A to Z, but from point A to point B, we have a section, we have a link. We've inserted loss by inserting devices, and that's necessary when we're trying to create a network. So the loss is being inserted because there is a physical connection, and we can't go around it. So we have to calculate and add it into the equation when determining our loss budget. So as this sticky note says, in its simplest terms, insertion loss is the amount of light that is lost as the signal arrives at the receiving end of the link. So everywhere it has passed through has created a place of loss. If we have too much loss on our fiber path, we're now impacting the signal flow from the transport gear. So if I send a signal from point A and it hits a patch panel, and then it hits another patch panel, and then it hits a splice, and it hits all these little things until I get to the end point, each one of those is designed to produce loss. But your job is to make sure the loss does not exceed what's in our loss budget. So there are certain things we can control. And one of those is when we make a connection and we pair a fiber physically, not through a fusion splice, but we connect it into a bulkhead. We want to make sure that these lock in place. We want to make sure that the cores are aligned the best they can. And we want to make sure that there's nothing impacting the signal. And the biggest thing that we see is if there's any dirt or debris on the end face of the fiber that you've popped into a patch panel, you're going to impact the signal. That impacts the performance. That impacts the loss budget. If we have too much loss on a link, we're not going to be able to produce we're not going to be able to deliver any quality services. So if any of you have attended, I used to give Fiber 101 seminars with EXFO, and some industry people have gone to those. If you know anything about the fiber end faces, when we're talking about fiber, we're talking about 4 contact surfaces when the fibers come together and pair up, right? We have the core, and that core in a single mode fiber measures approximately 9 micron. Some, there's 8 micron, but 9 micron core, to put it in perspective, if you pull out a strand of hair, an average strand of hair is about 70 micron in diameter. So we're going to be inspecting glass that is 9 micron in diameter. So you can imagine it's just a fraction in diameter as a human strand of hair. So there's not a lot of give there. Anything that gets in the way of the core is going to impact that signal huge. So there's standards to the 4 surfaces on the end face of your fiber of what is allowable and what is not. It has been known that approximately 80 to 90% of network problems can be directly related to the connector performance. So if you have bad, damaged, or dirty connectors, you can actually impact your network performance by 80 to 90%. So a little bit of dirt sitting on the core of your fiber can knock down a whole network. It's extremely important. We used to ask that rhetorical question, hey, who here in the room inspects their fiber religiously? And on an industry basis, you would get maybe 20%. 20% say, well, we do. We have some users out there that say, you know what, we know it's so important, we clean them. We don't even worry about looking at them, we just clean them. And although the thought process is right, yep, you know it needs to be clean, you're running into a risk of actually making a situation worse. So if you don't have an idea of what your end face looks like before you make that physical connection in that bulkhead or that patch panel, you could actually be making things worse. So again, in today's demonstration, I'm using the EXFO FTB1. I've launched the toolbox. You can see here in my toolbox, I have an Ethernet 10 gig tester. If I had an OTDR, it would be listed here. If I was using an OLTS, it would be listed here. But no matter what module that sits in my chassis, I always have access to my connector inspection software. And in the EXFO world on the FTB or MAX platforms, it's called CMAX 2. EXFO, they want inspection to be available to you. If you don't have your EXFO unit and you're out in the field and you need to inspect, I'll be using the EXFO 435B, which is their Wi-Fi probe. That one connects to any mobile device. If you have the 430B, it has a USB cord. You plug it in to any USB capable device. At the end of the day, they use the same software. I'm going to launch it. And if you have customers that connection's super important too, and they want to see all your end faces and make sure you inspected it, we have a file naming structure, ID. We have all these tools here to the right that will match up. You can label this stuff. You can define this stuff just like you would your OTDR traces or your OLTS shots. So you can pair all this information and create a reporting package if you needed to. If you guys want more information on some of the more advanced tools in doing anything on your EXFO boxes, in your connector Max, or any of the other applications, let me know, and I'll help you with that. First off, I've powered up my device. I'm using it via USB into the chassis. You can see I have a connection. This is a gray screen because it's not looking at anything. And I have certain controls. I can ask it. The 435B and the 430B have the ability to auto center, auto focus, auto capture, and auto analysis. Then I choose what connector type I'm going to test or inspect. Down here, the standard that's loaded is the IEC standard for a single mode fiber. UPC is the feral type with an optical or an ORL of greater than or less than 45 dB. And here's the standard. I'm actually going to inspect an APC fiber. So before I do an inspection, I want to make sure I'm inspecting that to the standards for the performance of that connector, that feral type. So you can see I have my choice of a single fiber connector, a transceiver, or a multi-fiber connector. I choose the tip, the feral type. I'm going to go standard because it's not LC and it's certainly not E2000. Standard. Now I'm going to go over to test config. Single fiber connector with a standard tip, but I'm looking at an APC. Choose that, close. And here on the bottom, you can see we will be testing this, inspecting this to the standard set for a single fiber APC. If using the EXFO inspection probe, you're going to choose the appropriate tip. And then each one, if you're using APC, there's a key on that tip. And it's designed to align with the key on the, I'm using an SC APC connector. I'm going to make sure that those keys are lined up. As soon as I plugged it in, it started taking the picture. I haven't pushed a button on this unit. And you can see with all that red highlighted stuff and the green, what this image is showing you is anything in red failed this inspection. The green things it measured, and those fell within spec. So you can actually have debris or you can have stuff at the end face that doesn't necessarily fail it and keep it from working efficiently. But based on the standards, this connector certainly is not going to perform. And then we're going to, basically, we could drop a whole network just at this connection. I put the, yep.
We actually had a question come in.
Yes.
It was said, Tammie, you mentioned bulkheads. How do you view or consider the possibility of a contaminated alignment sleeve?
So bulkheads are basically, for those, you know, we all use different vernacular, but a bulkhead is basically an alignment sleeve, right? It's designed to put two like connectors. So if I have an APC connector, which is always identified with a green boot, I can only marry that to another green booted connector. It has to be APC. And if I'm going to go, there are some, you know, there are some adapter alignment sleeves where I can go from a 2.5 or an SD connection to an LC, which is a 1.25. But basically, when I'm using a bulkhead, I'm taking two light connectors and I'm putting them into this bulkhead. And it's designed to make sure my cores align and my end faces align, so we can have a better chance at a better seamless transition as that signal crosses over between one fiber to the next. Now, most of the time, that is really just an alignment sleeve. It's designed just to keep two fibers connected in there, and you don't normally touch it. There are some times if you go into a site and hasn't been used for a while, dust has settled in, you can have dust that forms in that housing structure. So what we would do is pull out the fibers, make sure nothing's in there. You want to make sure that if you're inspecting the fibers, you're inspecting both of those fibers, because if there's dirt on one and you plug it into another fiber, you're going to transfer that dirt. So now you have two contaminated end faces. So you would remove them, and you can take some compressed air, kind of blow out that sleeve, because there's nothing in there that's a performance indicator. But if you want to make sure everything in that connection is clean, you can go in, dust it out, blow some compressed air. I would never advise blowing compressed air into a sleeve when you have a fiber plugged in at the other end, because you could actually, the pressure of that canned air can actually just really put any dust or debris in there pretty solid. So you'd want to make sure that bulkhead's clear, and then just clean the inside of the bulkhead. Inspect your two end faces, and if you get a pass, You can plug them in together. And now you've basically created a best chance performance right there. Everything is aligned, everything is clean, and this will not be a limiter in the transmission of your optic signals. Does that answer your question? Again, when you're in the field and you're doing your thing and you're splicing, when we splice and use our fusion splicers, we're doing the cleaning, we're in an environment where we can actually try to do it, you know, in the trailers and stuff, the tents, try to make it as clean as possible. So when you're doing these fusion splices, you're not inviting dirt and stuff into in that connection. But when we're outside and we're in the building and we're going into some of these huts, and we've got to make fibers going from one piece of equipment, jumping in, connecting to another fiber that takes it to another piece of equipment, and we're changing the routing. Every time we unplug those fibers, dust is going to basically settle on them. It can settle on them, I should say, depending on how your environment is. When we're talking about microns of debris, we're measuring them down to the micromillimeter. Unseen to the naked eye, right? We can't identify these things. We can't see them. You want to be using some sort of inspection device that takes the view out away from your naked eye. So you want a video scope. You want to be able to objectively see it on a screen. You want it to be able to analyze it to a certain standard, and then let the machine do the analysis. Let me think. I'm trying to find another way to stress the importance of inspection. Inspection it can be the most mundane job, right? Plug it in, push the button, whoop, there it is, pass, okay, set it in, do the next one, do the next one, do the next one. But it can be the most important part of that path. It can be the most important part of your network being capable of delivering 100 gig, capable of going to 100 gig, 400 gig. You know, this is just a little side note, but EXFO, and I can only speak from EXFO because I don't have experience with other manufacturers. EXFO is constantly trying to improve the technology, especially when it comes to inspection, because it is such an important part of our network path. They've come out with, we have a brand new release, and some of you may have heard about it, but there's now, because we're getting into multi-fibers, multi-connectors, so you have a little cassette, little tiny, a terminator, and there could be up to 12, 36, there's multi-fibers in one cassette, and it's designed to plug in to another one. And that way you're coming in with, 12 fibers, one connection, and you can imagine the capacity we can do with that. Well, we've got to keep up with that when it comes to inspecting that, because that's just as important as doing these single fibers. So EXFO has the new, if you have a 435B, you can get a multi-fiber nozzle, and it will allow you to look at all those little end faces that sit in that little cartridge. But they just come out with the FIP 500. Basically, it looks like a little gun, and it does an automatic analysis and a focus and centering. And there's no more manual advancement of the nozzle to look at all those fibers. It does it for you presto. It also has a nice screen with great resolution that sits on the device. It does single mode fiber, so it will be backwards compatible. But EXFO's trying to keep up with the evolution of our networks. And I don't know if anybody else has something comparable. And for those of you in the field that use different manufacturer hardware, maybe you know this. But if you guys are interested in any of these inspection tools, or you've come up across a problem, or your company's introducing new hardware, give us a call. We like to pride ourselves as being kind of an EXFO resource. We have, between Buck, myself, Charlie, Mark, Eric, the experience we have in the field, we can help you guys with decisions. Because before you guys do anything, when you're troubleshooting and chasing those ghosts and trying to figure out what the heck is going on, it could be as easy as finding a bad connection. Are there any questions at all? This isn't a super technical area, but it's very, very important that you guys know why and how, so you're not out there just spinning your wheels trying to figure out what is going on, because your inside guy says, I have an LOS and all my stuff's good. It's out there beyond our site. If there are no further questions, give us a call if you guys want to do some training, if you want to see some of the products, or if you would like to know more about some of the network troubleshooting. That's what we're here for. So don't be shy, call us, email us, and we just want to help you guys when you're out there in the field doing, the hard work. We want to make it easier for you. And that's why we're here.
Well, it doesn't look like I've seen any other questions come in. So I'd like to thank everybody. Thank you, Tammie, for your presentation. Again, to reiterate what she said, connector inspection and cleanliness is a major, major factor to that leads to issues on a network. I saw some numbers, something like 90 or 95% of most of problems can be traced usually to a bad connector, either dirty or damaged or something like that. And there's so much, and they can be the enemy of upgrades. Hey, we're working just fine at 1 gig. The network gets plugged in at 10 gig, and all of a sudden there's bit errors all over the place, or going up to 100 gig. So it's very important. Now, Tammie, a question did come in, and the question is best way to clean the fiber?
The best way, so when I looked at mine, when I first plugged that in, it was pretty nasty. Kind of looked like a Doppler radar system. And I used a one-click tool for my connector type. So you're going to buy them. They're kind of generic, right? You have the LC or the SC. SC is your 2.5 millimeter connector, and then your LC is your 1.25. So I simply took my 2.5, I plugged the end face in there, and I gave it 2 clicks. I've been known to, they've called me Tammie 2 clicks here in the industry, because when I use the 1 click, well, OCD kind of just, I had to do it twice. It was more fulfilling. But give it 1 or 2 clicks and re-inspect it. Now, some of us are like, wow, that looks pretty duty. I'm going to hit this thing like Tommy gun. I'm going to give it like 17 clicks. That'll clean it. We caution you, when you use a dry cleaning product on a dry end face, you have a risk of creating an electrostatic magnetic field. And dust is our enemy. So when you have the electrostatic magnetic energy, you're actually attracting dust. And your ferrule, if you were to look at the architecture of a ferrule, you have the shaft, you have the beveled ends, you have a cladding, you have the core, and you run that click too many times, you could be bringing dust and dirt up that might be sitting in that ST housing. So 1 or 2 clicks, inspect it. If it looks like it has improved, and you're like, wow, okay, I'm going to do this 1 or 2 more times. If it's not improving too much, I would say to move into a hybrid cleaning, and that would be using one of the solutions on the market. You want to make sure it's fiber and face friendly. A fiber and face friendly solution has like conditioners and moisturizers in there to make sure that we're not drying out that glass and that composite housing. So just a little spray or 2, one of the little electro wash pens, put that on your cube and run your end face over it. So you've over the wet, draw it down into the dry. So we've moistened it and dried it. Kind of give it a, a little, I don't want to say polish, but it's kind of like just a slow polish. And then inspect it again. If you've done 3 or 4 inspections and it is not improving, then I would call it bad. And maybe there is a bubble in there. There could be burnt on dirt, and it may never improve. So then you're looking at just getting a new fiber. If it's sitting on a patch panel, you might want to bring out a fiber polisher, give it a nice polish, or actually cut it off and do a splice-on connector and put a new connector on that fiber. So we would always hit it with a dry cleaning product, your cleat tops, your cubes, your 1 clicks, and then turn it up a little bit, add one of the wet products with the dry, and if that doesn't improve it, you could almost suspect you have a damaged connector, and it's not going to get better. Are there any other questions? I do thank you guys for your attendance. We really try to make sure we can do some of these, you do this for so long and you start thinking, well, everybody knows this. And as we find more people coming into the fiber field, coming in from the low voltage houses, taking your, we have some internet service providers, a lot of new blood in the industry playing with glass. And we just want to make sure we're all doing this to a best business practice. You guys might be using another vendor, but the process is the same. Inspection. Buck has shirts on his business card, on his luggage tag. Scope, clean, scope, connect. ICIC, SDIC, inspect, clean, inspect, connect. Without an inspection, you just don't know what that connector's doing. And you're going to see this on an OTDR because you're going to have a nice big spike of reflectance. And that's going to let you know that there's a place where the signal is actually hitting the air. That's what I call it, my air gap. So, this is the most mundane part of the job. But like Charlie said, numbers suggest it's pretty important, and it directly impacts our loss budget. Thank you, everybody.
Thank you. And as I said, we recorded this. We will send out the link to everyone. And if there's any questions, please don't hesitate in reaching out. And I thank you and have a wonderful day.
Thank you.
This